I'm going to tell you about quenching and give you the answer to these questions. Why can quenching operation increase the hardness of steel? And why does the steel become brittle? Firstly, we are going to define what the term of hardness exactly means. Here is a steel, and you have a strong hammer. What if you hit the steel with the hammer? You all know that the steel will have a dent, right? This dent, I mean permanent deformation, is called plastic deformation. The term of hardness is defined as the resistance against deformation. The idea of this definition will enable you to understand some studies in material field more easily. Actually, in hardness test, you use a hard needle and press the material with standard force. The material is going to deform, and you measure the depth of the deformation to evaluate the hardness. That's why, if you'd like to know the exact meaning of hardness, you need to understand what plastic deformation is. So, let's see the mechanism of plastic deformation. You are looking at metal atoms, and you will see how plastic deformation occurs. Let's try applying force on the atoms. The atoms moved a little. I will increase the magnitude of the force. At this moment, the metallic bond cannot bear the force anymore, and the metallic bond breaks. Eventually, plastic deformation occurs. Is this how it works? Actually, this is not a fact. Then, how does plastic deformation occur? This metallic bond is so strong that you cannot break it easily. However, it will be much easier if you try to slide the atoms one by one. I will show you how this really happens. Okay, in the first place, this structure does not exist. Actual metal has a defect like this. This defect is called a dislocation, and it is usually expressed by this symbol. If you apply force on this metal, the dislocation will move, as you can see. So, if you can say that a piece of metal has plastic deformation, it will be the same as dislocations moving around. In the beginning of this video, I told you that hardness is the resistance against deformation, right? So, you can say that to become harder is the same as dislocations becoming difficult to move around, okay? But why does it happen? Let me give you the answer. You are looking at steel that is heated up. You have heard of the word steel many times, right? But what is steel? Steel consists of iron and carbon. This smiling face is an iron atom, and this smiling face is a carbon atom. This is what I introduced a while ago. Dislocation. If you heat steel more than a certain temperature, the steel changes its crystal structure into this chart called austenite. Iron atoms and carbon atoms exist together in peace in austenite. You see ions and carbons smiling. If you cool austenite slowly, the austenite will change into this chart. I'm not going to discuss technical terms like this crystal is ferrite and these are pearlite. What I'd like to tell you is that the atoms in these crystals look comfortable. I mean, the structure does not have much stress. Then, what if you cool austenite rapidly? The austenite will change into this chart called martensite. Okay, now we are going to compare these with each other. The ions and carbons in these crystals, which we cool rapidly, look stressed. It's because the crystals could not have enough time to change into this kind of peaceful situation. I mean, the transformation unfortunately ended, and carbons exist possibly against ion crystal structures, and which means there is much stress in the crystal structures. The stress prevents the dislocations from moving around easily, okay? In addition to that, since these crystals transformed without enough time, the number of dislocations increases. And when many dislocations try to move around, they get easily tangled, and eventually, the dislocations stop moving around, even if you apply strong force on the crystals. The third difference between these is that these crystals become smaller than these, because, again, it doesn't have enough time for the crystals to grow up. So the number of the crystal boundaries increases, and then the dislocations become difficult to move around through crystal boundaries. Moreover, if the size of the crystals becomes smaller, the number of dislocations that are accumulated in this crystal decreases, and the dislocations force that pushes a crystal boundary also decreases. So, the dislocations in this small crystal cannot break the boundary. That can be one of the reasons why dislocations cannot move around easily. The last difference is that the steel you cool rapidly has carbides. These carbides prevent dislocations from moving around. These are the reasons why quenching process makes steel hard. Dislocations become difficult to move around. That's the reason. In the next part of this video, I'm going to give you the answer to this question. What does the term brittle exactly mean? The opposite word is tough. And this term means the metal has a high ability to absorb energy. So, the term brittle means that the metal cannot absorb energy. In other words, you can break the metal without much energy. Okay, we are going to be more specific. Here are two types of metals, metal A and metal B. You apply force in the amount of 6,000 on metal A, and the metal gets stretched by the amount of 1, and then the metal gets broken. While on metal B, you apply force in the amount of 3000, which is weaker than this force. And the metal gets stretched by the amount of 3. And then it gets broken. So, the energy that metal A absorbed is 6000 times 1, which is 6000 worth of energy, while the energy that metal B absorbed is 3000 times 3, which is 9000 worth of energy. Now we can say that metal B is tougher than metal A, and metal A is more brittle than metal B. Okay? Now you have a clear idea of the terms brittle and tough, right? I'm afraid, but I need to tell you something you should be careful of. These values are something related to energy, but they are not energy. I mean, the amount of force times elongation cannot become energy. I'd like you to be careful of it. The other point I should mention is that a piece of metal that can stretch long is not equal to a tough metal. I mean, it may be tough, it may not be tough. I will say this again. Tough means the metal has a high ability to absorb energy. Tough does not mean the metal can stretch long. I'm going to go back to the topic about quenching. Steel that has undergone the quenching process is hard because of these, as I told you. But why? Do you still remember it? Dislocations cannot move around easily, right? That's why steel becomes hard. So, you need large force for the dislocations to move around in order to break the steel. It is true that you need large force. However, the large force breaks crystal boundaries and weak parts in crystals in one sitting without elongation. So, you don't need large amount of energy to break the steel that has undergone the quenching process. Let's call it a day. I hope that you understood the reason why quenching operation can increase the hardness of steel and the reason why steel becomes brittle. See you in my next video.